Hello students, welcome to our next lecture. Uh, we were discussing about process management. We had picked that what is program and what is process. Then we moved that how we represent process in memory. So we had picked the data structure which is used to represent process in memory, that is process control block, which is also known as PCB. We had picked that which kind of information it contains and why it contains different kind of information. Then we moved into one specific information which PCB holds, that is process state transition diagram. We were discussing about that what is state transition diagram, what is process state, why any process requires state. Then we moved that there are multiple models and the most basic model is two-state model, where we had picked that process will enter here. The process is going to enter and it will have only two things. One is running and another one is not running state. This running state and the next one is not running state. Now we had picked that running means the process is going to execute in CPU, and not running means that if anything happened to the process, that suppose process newly got entered or loaded into the memory, or due to certain time stamp it removed from the CPU, or due to certain IO operation it moved out from the CPU. So each and everything will be in not running state. So that is two-state model. Then we also picked that why we require more state. Is this two-state model is more than sufficient? Then we picked that no, it is not more than sufficient, because this model do not represent the reason for waiting. Means so many things get combined into one specific state. Hence, we got the opportunity that we can divide that not running state into multiple states, and this becomes basis for our next model, that is five state model, where what we have, the process get moved from multiple state. The first state is new state. Now what is new state? New state is that when process gets created, it is in new state. So suppose I have a hard disk, and suppose this is my RAM and this is CPU. So CPU, this is my RAM, and this is my hard disk. Now, when something resides here, it is program. So if you want to make process, what you need to do, you need to load that thing into memory. So when you double click here, this becomes a new process and it should move into the RAM. So that is that when you double click and the process is about to move to the RAM, it is known as new state. That you are saying that now it is going to load into memory. Next one which we had given, that is running state, means when process is in CPU, it is known as running state. Next is waiting. There is a possibility that after running, you want to send that process for certain IO. So what it will do, it will wait for that IO. Hence, it is in waiting state. So due to certain event occurrence, it moved from running to waiting. Then we have ready state. Now what is ready? When process is in RAM and now it is ready to move into the CPU. Hence, it is known as ready state. And the last one is terminated state. When process got completed and it get exited, then that is known as terminated state. So we have five different states. Now let's again pick that how they are organized. So I'm picking the same thing again, that first of all, what will happen? The process got created, and when the process got created, it is in new state. New state means process got loaded into memory. Now when process got created and now you want to load into memory, then you will say that okay, process is loaded into memory and now it is ready for execution. So many processes got loaded into memory. Then which process is ready for execution? Then that process is in ready state. After that, the process will move into running state. Now, in running state, process is running into the CPU. Now, after running, there are two possibilities. First, either process gets terminated, means it has completed its task, or what will happen, it will move for certain waiting state. Now, why it is moving for waiting state? We had already discussed that suppose that process wants to do certain IO, and for that particular IO, it need to leave the CPU. Now, why it required to leave the CPU? Reason that if that process has already acquired the CPU and it is waiting for IO, then there is a total waste of this CPU. It can be given for any other process for running for achieving multi-programming. We had already picked the concept of multi-programming pipelining. Hence, what we can do, we can leave or process will leave the CPU and it will move to the waiting state. After completion of its task, what it will do, it will again move to the ready state, that now I am ready for execution and I should again get the running state. Now there is few more arrows. uh, for example, it's a simple question, that can we have arrow from directly running to ready state? The answer is yes. We do have direct arrow from running to ready states. Be careful, each and every arrow is having its own meaning. So whenever you are having any arrow, it reflects certain kind of meaning. So be careful. Do not write arrows without knowing, or just for the sake of that, okay, I can move from this state to that state. Everything is fixed and everything is having certain kind of justification. Now, what is reason behind moving from running to ready? And the thing is that there is a possibility that certain process, due to certain interrupt, as we already know that there are two kind of interrupt. One is maskable interrupt and the one is non-maskable interrupt. So suppose any non-maskable interrupt came, and non-maskable says that you cannot uh, hold that interrupt. So what it need to do? That interrupt will require processing into CPU. Hence, you need to forcefully send out your process from CPU to the ready state. And this becomes one important aspect, that why we should have direct arrow from your running state to the ready state. So we can say that yes, this is perfectly fine, that I can have any process moving from directly running to ready. Now, this is the overall five state transition diagram. Now, I have few questions. The question is that can we have this arrow? Is it possible? Or can we have this arrow? So I'm sure you will search out for these answers and we will discuss in our next lecture. Thank you.